Hello, we're in Helicopter Flying Handbook, Chapter 2, Aerodynamics of Flight, page 6 of 28. Just went over drag, and we're going to go over airfoil. Helicopters are able to fly due to aerodynamic forces produced when air passes around the airfoil. An airfoil is any surface producing more lift than drag when passing through the air at suitable angles. Airfoils are most often associated with production of lift. Airfoils are also used for stability, fin control, which is elevator, and thrust or propulsion, which is the propeller or rotor. Certain airfoils, such as rotor blades, combine some of these functions. The main and tail rotor blades of the helicopters are airfoils. The air is forced to pass around the blades by mechanically powered rotation. In some conditions, parts of the fuselage, such as the vertical and horizontal stabilizers, can become airfoils. Airfoils are carefully constructed to accommodate a specific set of flight characteristics. Airfoil terminology and definitions. Blade spin. The length of the rotor blade from center of rotation to tip of the blade. That's the blade span. Chord line. A straight line intersecting the leading and trailing edge of the airfoil. That's the chord line. The chord. The length of the chord line from the leading to trailing edge. It is characteristic longitudinal dimension of the airfoil section. Mean camber line. A line drawn halfway between the upper and lower surfaces of the airfoil. Alright. The chord line connects the ends of the mean camber line. Camber refers to a curvature of the airfoil and may be considered curvature of the mean camber line. The shape of the mean camber is important for determining aerodynamic characteristics of an airfoil section. Maximum camber, displacement of the mean camber line from the chord line, and its location help to define the shape of the mean camber line. The location of the maximum camber and its displacement from the chord line are expressed as fractions or percentages of the basic chord length. By varying the point of maximum camber, the manufacturer can tailor an airfoil for a specific purpose. The profile thickness and thickness distribution are important properties of an airfoil section. The leading edge, the front edge of the airfoil, the flight path velocity, the speed and direction of the airfoil passing through the air. For airfoils on an airplane, the flight path velocity is equal to true speed, TAS. For helicopter rotor blades, flight path velocity is equal to rotational velocity plus or minus a component of directional airspeed. The rotational velocity of the rotor blade is lowest closest to the hub and increases outward towards the tip of the blade during rotation. Relative wind. Defined as the airflow relative to the airfoil and is created by movement of an airfoil throughout the air. This is rotational relative wind for rotary wing aircraft and is covered in detail later. As induced airflow may modify flight path velocity, relative wind experienced by the airflow may not be exactly opposite at its direction of travel. Trailing edge, the rearmost edge of the airfoil. Induced flow, the downward flow of the air through the rotor disc. Resultant relative wind. Relative wind modified by induced flow. Angle of attack. The angle measured between the resultant relative wind and the chord line. Angle of incidence. AOI. The angle between the chord line of the blade and the rotor hub. It is usually referred to as the blade pitch angle. For fixed airfoils such as vertical fins or elevators, angle of incidence is the angle between the chord line of the airfoil and the selected reference plane of the helicopter. Center of pressure. The point along the chord line of an airfoil through which all aerodynamic forces are considered to act. Since pressures vary on the surface of an airfoil, an average location of pressure variation is needed. As the angle of attack changes, these pressure changes and center of pressure moves along the chord line. Airfoil types. Alright. Symmetrical airfoils. The symmetrical airfoil is distinguished by having identical upper and lower surfaces. The mean camber line and chord line are the same on a symmetrical airfoil, and it produces no lift at zero angle of attack. Most light helicopters incorporate symmetrical airfoils in the main rotor system. Figure 2.1. The upper and lower curvatures are the same on the symmetrical airfoil and vary on non-symmetrical airfoils. Non-symmetrical airfoils. Camber. The non-symmetrical airfoil has different upper and lower surfaces with greater curvature of the airflow above the core line than below. The mean camber line and the core line are different. The non-symmetrical airfoil design can produce useful lift at zero angle of attack. A non-symmetrical design has advantages and disadvantages. The advantages are more lift production at a given angle of attack than a symmetrical design, an improved lift to drag ratio, and better stall characteristics. The disadvantages are center of pressure travel up to 20% of the core line, creating undesirable torque on the airfoil structure and greater production cost. Alright, so blade twist. Because of lift differential due to differing rotational relative wind values along the blade should be designed with a twist to alleviate internal blade stress and distribute the lifting force more evenly along the blade. Blade twist provides higher pitch angles at the root where velocity is low and lower pitch angles near the tip where velocity is higher. This increases the induced air velocity and blade loading near the inboard section of the blade. Rotor blade and hub definitions. Hub. On the mast is the center point and the attaching point for the root of the blade. Tip. The farthest outboard section of the rotor blade. The root. The inner end of the blade and the point that attaches to the hub. The twist. The change in the blade incidence from the root to the outer blade. The angular position of the main rotor blade is measured from the helicopter's longitudinal axis, which is usually the nose position of the blade. The radial position of the segment of the blade is the distance from the hub as a fraction of the total distance. Alright, in case we don't look at this later. Pictures. That was for drag, the last one. Alright, so we'll hold off there. That was the airfoil types. Pretty much airfoil types and blade twist, and that's ending on page 8 of 28. Yep. All right, and there was that last picture. All right, 8 of 28 in chapter 2, Aerodynamics of Flight, Helicopter Handbook. See ya.